Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. My name is Associate Professor Dr. Ahmad Mazi bin Hilmi. I am a lecturer in University Malaysia Perlis. Uh, I'm also the creator of software thesis, which I created myself, and my brother Mazaim is the programmer for the software. Okay. Uh, in this video, I'm going to talk about sustainable manufacturing, which is a subject that I teach in for master's level. Uh, this topic is a lecture. It's a lecture class, lecture note for those who are interested. You can hear from the beginning, and I will save this video. I will save the video, and I will upload into the to the social media lah. Okay. So introduction to sustainable manufacturing. Okay. Integrating social and economic and environmental dimensions for future ready production. This is the book that I've made. Okay, this is the book that I've made. You can search the book lah. You can search for the book. Okay, later on. Okay. What is sustainability in manufacturing? Okay. Sustainability is multifaceted sustainability. It integrates social, environmental, and economic dimension to promote responsible production. Uh, we uh, we want to minimize environmental effect and aim to reduce pollution, conserve resource, and limit waste generation across supply chains. Okay, and it involve with emerging standard and technologies and global mandates towards greener operation. Okay, so we want our production to become sustained. Okay, meaning that the flow of the raw material is smooth flowing. Uh, no no uh, no help in the production and everything, so it will become the smooth flowing lah. So this is what we aim lah. Okay, there are many definition of sustainable, so we focus now in sustainable in manufacturing. Okay. The subject that I will teach is for master level for manufacturing students. So this is the book that I made lah. This is the content of the book. Okay. Importance of sustainable practice across industry. So we have the global environmental challenges, addressing climate change, resource scarcity, and ecological degradation in manufacturing, because everything involve everything lah. Climate change, like let's say with the climate change, maybe some of the fertilizers, some of the food that we consume cannot be produced because of the climate change, the flooding, the weather, it will affect the economy lah. Kan? Circular economy adoption. So prioritize by recycling, reusability, and efficient resource can reduce waste. Okay. So wherever that we can recycle, we try our best to recycle. Okay, of course, recycling also needs cost. Okay, there are costing for to recycle products, but if we can recycle, we recycle. Okay, demand for ethical production align with customer expectation for responsible and sustainable manufacturing process. Okay, so ethical production. So like say for the timber company, who cut the trees in the forest. So ethically they must replace the trees, for example lah. Okay. So that is for example for ethical production. The same goes for you hiring a person. You must pay the person according to the time, uh, uh, according to the salary and everything lah. This is for example of the ethical production. Okay. So talking about sustainability, we are talking about three pillars of sustainability, which is social, economic, and environmental dimension of sustainability. Okay. Now we're talking about social sustainability. They are worker safety and well-being, which is we promote safe, supportive work environments, prioritizing human and health and safety. Okay, we must take care of our workers and all the supporting industry uh, that will support us. Okay, fair labor practice, ensuring ethical treatment, fair wages, and community engagement in manufacturing. So, like for example, in Malaysia right now, there are minimum wages. Yeah, the minimum wages, 1,700 minimum wages that must be implemented for our workers. So uh, these are the things lah. Then human centric industry 4.0. Okay, nowadays people talking about 4.0, 5.0, and later on 6.0 and 0.0.0, okay, these things that this human-centric industry lah, emphasize collaboration between worker and machine, because now nowadays we know that artificial intelligence will definitely uh, in the trend now. So uh, we must collaborate with workers, machine, and also AI, actually artificial intelligence, to enhance productivity and inclusivity. Okay. So we're talking about economic sustainability, which is I will make another video and another book. I will discuss another book, another video on economic, social sustainability, and environmental sustainability. Focus on that book also. So for economic sustainability, there are resilient business model, adaptive manufacturing strategies to mitigate market fluctuation and resource dependencies. Circular economic approaches emphasis on product longevity, reusability, and efficient resource allocation. And MSIF, multi-source information fusion, integrates data to enhance resource optimization and economic viability in manufacturing. Okay, so these are the things. And the last pillars is environmental sustainability, which is like emission reduction strategies for lowering harmful emission, including low carbon technologies and cleaner production methods, resource optimization, efficient use of resource through data-driven decision for to reduce waste in production, and waste management improvement, innovative waste reduction and recycling effort to minimize environmental effect. Okay, environmental impact. So this is the things for these are the three pillars for sustainability, which is social, environmental, and economical sustainability lah. Okay, okay. Talking about social sustainability in manufacturing. Okay, uh, okay, focusing on social sustainability, we have the workforce development and skill evolution in industry for 5.0. Okay, 5.0, if you heard about industry 4.0, it is about working with human and machine interaction. Okay, that time when the term 5 4.0, they coined the term for 4.0, there is no artificial intelligence yet that time lah. Now, with advancement of artificial intelligence, okay, they coin another term. Okay, industry 5.0, because it is combination of three things. Okay, AI, human and workers, and worker, human and machine, and AI. Okay, combine three things. Okay, so transition to industry 4.0, 5.0, industry 5.0 emphasis human technology collaboration, enhancing skill adaptation in areas like AI and robotics to improve productivity and sustainability. Development of cross-disciplinary skill, focus on skill that emerge technological proficiency with problem solving, teamwork, and social and environmental awareness to align with industry 4.0. And training and upskill initiative, and organization are adopting upskilling programs to close gaps, fostering continuous learning to match industrial landscape. Okay, so this is the things that important. Nowadays, workers must be multidisciplinary, must know what other things that are not so related to what they are study in their degree time. Okay, for example, mechanical engineers must know something about electrical, must know something about programming, or even though they are not so expert at that in that field, because they don't learn in their degree time, but uh, uh, somehow it has to know lah. That's why they go for training and everything lah, for exposure of this new technology. Okay, of human-centric design and role of operator 4.0. Okay, operator 4.0 framework focus on workers and enhance uh, AR and VR interfaces, like the picture depicted in the picture here. The person wear VR headset, exoskeleton and wearable technology to boost economic and productivity. Emphasis on economic and safety, industry 4.0, leverage human-centered design principle to reduce physical strain and enhance safety and operator well-being, and enhance human-machine collaboration, promotes real-time feedback and decision making through augmented interfaces, allowing workers to engage in higher order tasks. Okay, uh, we still need human. Okay, we still need human because human Allah give to us, is we are very good in decision making. Okay, robot cannot do that. Okay, robot cannot do that. As for the time I'm giving this lecture, robot is not able to for decision making. Okay. uh, but we don't know what the about the future later on lah. We do not know. Okay, but what maybe in the future robot can do decision making. Okay, but human, we can do decision making, and we have the tools our hand to judge and to do things that robot cannot do lah, for the time being lah. This is why, because a human also have limitation, because we are fatigued, we are tired, okay, we are hungry, everything. So this is the things that will boost our productivity lah. If we attach, uh, we have to reduce our physical strain and have safety and everything. So we wear wearables, exoskeleton and everything. So the productivity will be boost. Okay. Ethical consideration and social impact. Okay, worker safety and inclusivity focus on creating safe work environment, fair labor practice, and inclusive opportunities to vulnerable workforce. Ethical sourcing and fair wages. Adopt responsible sourcing, fair compensation, and long-term impact consideration in manufacturing practice. And environmental responsibility aligns with sustainable practice to minimize environmental impact and prioritize ethical standard across production. Okay, so. We know that there are some countries have child labor and everything. So maybe we think that it's non-ethical, but in their perspective, they don't have job and everything. So this is the things that we have to consider lah. Maybe it's fair for us, maybe it's not fair for them and everything, but these things have to consider everything lah. Okay. Case study on human machine interaction is sustainable for smart factories. So enhance human machine interaction, HMI, human machine collaboration in smart factories, prioritize efficiency, safety and economics through sustainable practice. Role of AI, artificial intelligence and robotics, AI-driven system enable real-time data analysis and task adaptation, minimize manual tasks and boosting operator manage engagement. Sustainability and socially responsible practices. Factories integrate circular economy principle, reducing waste and promoting long-term social sustainability. Yeah. Okay. We talk about focus on economic sustainability. Okay. There are principle and goals. Okay. Sustainable resource management, focus on reducing waste and optimize resource utilization to enhance efficiency. Okay, we don't want we must reduce waste. Waste will happen. We must reduce waste. What is the waste? The time also wastage. Okay, the electricity, the raw material, these are things that are waste. Okay, that's considered as waste. We don't want to waste time, because time is equivalent to money. You learn about waste management in another subject, better for in lean manufacturing. Okay, this one semester subject on that. Okay. Adaptation of energy efficiency technology, implementation of advanced technology like cogeneration and renewable energy, clusters for energy saving, and long-term financial viability, establishing framework that support long-term profitability through sustainability-driven innovations. Okay, so let's say our company is very dependent for certain raw material. Okay, what will happen that for if that raw material finish like petrol? Okay, eventually it will finish. What will happen? We must have an alternative for that lah. So that's okay. I give example lah. Okay. Role of technology in improving economic efficiency. So this is the things that researchers in the university level, they do this kind of research. Okay, like nanofluid interpolators, advanced heat transfer techniques like nanofluid interpolator enhance energy efficiency. Okay, by improving heat transfer rates, renewable energy cluster integration of renewable energy cluster support cost reduction and promotes local job creation. Okay, and optimize biomass cogeneration. Use of control strategy in biomass cogeneration leads to better economic and environmental outcome by maximize energy production. Okay, this is the things that um, we have to engage with university. We have to engage to researchers to do this research for us, and of course it will benefit lah. Will benefit everybody lah. Okay. So economic optimization in supply chain. Okay. Integration of multi-source information fusion. Okay. MSIF. Data-driven decision making. Okay. Because if we want to decide something, we must have data. Must have data. Uh, and then we can decide. Okay. Okay, enhance circular supply chain. MSIF enable efficient byproduct reuse and end of life returns, boosting supply chain sustainability and cost effectiveness. And predictive analytics in material usage. Machine learning algorithms predict material properties, optimize usage, and reducing manufacturing costs. Okay, so that we use the technology like machine learning uh, to help us determine what is a suitable material for production and everything. So uh, for the senior guy, for senior operator, have worked long in the industry, they know how to do it. Okay, but for the junior one, they must learn from the senior. Okay, maybe machine learning algorithm can help boost the learning curve lah. And strategies for environmental and economic balance. Okay. Okay, incentive for carbon capture. Policies promote carbon capture, utilization, and storage to support eco-friendly manufacturing practice. Okay, so because nowadays we concerned about the sky, okay, we concerned about sky, carbon, and everything. So greenhouse effect and everything. So they we want to reduce lah all these things that we can reduce. Okay. Tax benefit for green investment, tax credit for companies that adopt renewable technologies that have sustainable transition to manufacturing. Malaysia also have this tax benefit. Okay. And circular economy frameworks. Policies encourage resource reuse and waste reduction, aligning with carbon responsibility goals. Okay. If we can, if we observe the waste side, okay, the lorry that take your rubbish at the front of your house and then they dump somewhere. Okay, there is lot of resource of that we can reuse it. Okay, we can use it. Provided we have all the tools and necessary tools lah. Okay, because if want to reuse it, also costly lah. Actually, is also costly. Everything is cost. Okay. So case study floating power, PV power, green hydrogen. Okay, floating. The keyword is floating. Why floating? Okay, because when this thing is float, okay, it will have natural cooling process. If we put, that is why this floating solar panel, they put on the lake, on the ocean, and everything, so that it has the natural cooling by the water by the sea, okay, by the cooling effect of the water from the ocean. It have the cooling effect. Okay, so it is save cost for cooling. Okay, rather than you put on the land, you have to clear everything up and have to have an additional extra energy to make it cooling. Okay, so this is the green energy lah. Okay. Environmental sustainability in manufacturing. Okay, sustainability principle focus on reducing negative environment impact by minimize waste, energy use, and emission in manufacturing process. This is the sustainable goals for environmental lah. Okay, so we have to key principle in circular economy in manufacturing. So there are resource efficiency, promote reuse, like recycling and remanufacturing to minimize waste and optimize material use, and also shift from circular linear to circular models, move away from extract use dispose pattern to regenerative system that limit resource extraction, and design for longevity, encourage for designing product with long lifespan, facilitate reuse and repurposing of material. Maybe design for longevity. Uh, I also I think it's not agreeable for this time now. Okay, you see the European cars built is built for the long lasting time. Okay, so but you see the smartphone, like you have the smartphone right now. Okay, after you buy, After 1 year, another brand of smartphone come. Okay, the lifespan is short. The lifespan is short. Okay, this thing, maybe we want to design for longevity so that we can use for long time. Okay, but naturally for this time of age, currently, people will get bored with the current product. Okay, this is the trend right now lah. Okay, so maybe design for longevity is not true anymore lah. Is correct for certain case, but most of the time maybe it's not that correct lah. But it's okay, kan? It's okay. Whatever pun. Adopting closed loop apa supply chain. Okay. Recycling end-of-life product allow waste material and byproduct to re-enter production and reducing waste generation. Okay, recycle. Lowering material cost, reduce recycle inputs, reduce the need for raw material, lowering overall production cost and competitive advantages, improve brand reputation and enables complying with eco-friendly standard. Again, when you want to do recycling, it's also need cost. It's also need cost, the machinery, the tools needed, the labor cost to do recycle and everything. Some things that you can recycle, some there are things that you cannot recycle. Let's say for 100% of the product, maybe 60%, 70% you can recycle. That 40% that you cannot be recycled, you must dispose it. Okay, the things. Okay. Life cycle assessment and carbon footprint reduction, evaluating environmental impact, analyze stages of production from raw materials to disposal, identifying high impact areas, guiding carbon reduction strategies, pinpoint strategies for emission cuts, facilitating for more sustainable production, and sector specific application utilizing automotive electronics to optimize materials and reduce supply chain impact. So this is the things that we want because uh, we want to reduce the carbon footprint, okay. So people talking about environment and everything, about the sky, everything. So this is what we want to do lah. Okay. So green technology for resource recovery, recycling lithium ion batteries. So nowadays, electric vehicles are in the trend now. Okay, you can see everywhere electric vehicles are on the rise right now. Because people are concerned the petrol will be finished eventually. So we replace with electric vehicle. The problem is electric vehicle is the lithium ion. Okay, lithium ion. Okay, so we want to recycle the lithium ion. So the battery itself will become a problem in the future. So there are researchers doing this kind of research to how to solve this disposal of lithium ion batteries lah. Okay, energy efficient machinery technologies like closed loop water recycling reduce waste and energy consumption, and uh, example like biomass cogeneration reduce reliance on fossil fuels and promoting cleaner production. Okay. Okay, this is a case study. I just want to skip to the latest. This is the things that also important. Okay, data latest advances in sustainable manufacturing. I get this information from the survey thesis that I created, which is extract all the journals related to the sustainability. So this is the latest advancement in sustainable manufacturing. Okay, there are data-driven manufacturing, integrates machine learning and data analytics to enhance resource efficiency and reduce environmental impact. Also, adaptive automation combines human cyber physical system to adapt to process in real time and improving precision and reduce waste, and visual simulation for real time monitoring and predictive maintenance, minimize energy and resource usage. Okay, and like for example, using data-driven decision making in sustainable urban environment, they use the resilient bioethanol supply chain, machine learning and mathematical model enhance bioethanol supply chain in adaptability in fluctuation in resource availability and demand. AI predictive modeling, okay, predicts supply and demand changes, reducing waste and cost and resource strain in urban manufacturing setup. Circular economy support, advanced analytics and enable renewable series of optimization, okay, fostering a sustainable circular economy. Okay, AI-based predictive modeling for sustainable supply chain, which is enhanced resource efficiency and reduce cost. Also enhance resource management, improve operational efficiency, and reduce environmental impact. Okay. and the adaptive automation and cyber physical system, HCPS, which is focused on human centric technology industry 4.0. Okay. It integrates BR AR with automated system to enable real-time adjustment, improving safety and precision. Real-time meditation, automation adjust parameters based on live data, reducing waste and enhance efficiency, and enhance worker safety, minimize physical strain and reduce error rates, promoting a sustainable work environment. Okay, so adaptive automation in sustainable manufacturing. Okay, we have the real-time efficiency. Uh, Automated system adapt to live data, reducing downtime and saving energy. Error minimization, human oversight with automation, reduce error and enhance precision, reducing waste and energy and resource conservation, which is we optimize machine operation, reducing the environmental impact and manufacturing process. Okay, digital twin. Okay, what is a digital twin is basically you have you sit in the office, you have the actual machine on the shop floor, and then you can monitor from your office. Okay, it's just simple as that lah. It's not that simple, but is try to understand like that lah. Okay, we have the real right time monitoring, and enables continuous monitoring of machinery and reducing downtime, predictive maintenance, forecast maintenance needs, extending equipment lifespan and reducing resource usage, and visual testing simulates production changes in the digital environments, conserving physical resource. Okay, challenges in sustainable manufacturing. Of course, there are challenges. Okay, barriers. The viable regulations globally create difficulties because rules and regulation in Malaysia is different from Singapore, is different from Indonesia and all over the world. So what standard that we have to use? We have the standard ISO and everything. So, but the policy, the company policy, the nation policy is different from okay. So we have to compromise everything lah. Kan? Policy fragmentation is consistent policies on emission and waste management hinder cross national sustainable effort. Okay, necessity of collaboration achieving SDG, apa SDG goal lah. Okay, requires cooperation across sectors, challenging yet essential for impactful change. Okay, integration barriers and policy change. Okay, uh, regular inconsistency different in global uh, difference in global regulation hinder adoption of uniform eco-friendly, lack of standardization, inconsistent use of sustainable materials due to outdated regional standard, and limited policy support, critical area like carbon capture and recycling, face limited policy backing and slowing innovation. Okay, I, uh, I think that's for the video right now lah. Oh, this is the last slide. This is the last slide. Okay. Cross sector collaboration and technology access, role of collaboration in sustainable manufacturing. Important of collaboration enable resource sharing and development with sustainable solution. SME support, close partnership, help small and medium enterprise access sustainable technology, because we want to implement sustainable technology is expensive. Okay, let's for example, you want to implement the blockchain and artificial intelligence facility in your company can afford it, but maybe SMB, small medium enterprise company cannot afford the system. Okay, this is the things that we have to share. What we can share, we can share. Okay, so that's all for the video right now. Okay, for those who are interested, you can get my book lah, and I will upload the video after this. Okay, thank you very much. Inshallah, we meet again. Assalamualaikum warahmatullahi wabarakatuh.